Alright, we are live now. I'm going to give it a second because we're a little early while we wait on some more people to join. Sure, let's update iTunes. That can't hurt. Alright, so we are on actual lesson 4. Again, I apologize. I gave y'all lesson 5 earlier, not lesson 4. I'll have to go in and change the title of the video after this. The last video, not this one. And that will do it for us. I like seeing all the participation. That's great. Makes it easier to do. I haven't talked to a actual person all day. I think somebody called me a couple times, but I haven't talked. It's hard to do this without interacting with people. So it's nice to see that people are on the other end and participating in what I'm doing. Thank you all for your buy-in and all of that. Yeah, just wanted to let y'all know that. All right. In the United States, electrical conductors are most commonly sized to the dimensions of the Oh, excuse me. That is the American wire gauge. All of you got it. No need to say any more about that. Calculate the resistance of a piece of copper wire with a diameter of 16.2 mils and a length of 15,840 feet. I like this one. Given that copper has a value of 10.4 K. So, Control A, delete. Alright. So, the formula for this, and I'm not entirely sure where this will be in the book, but the formula for this will be don't have a pencil. Okay. R equals the K value of the material times the length over the area in circular mils. So for this one, copper is 10.4, 15,840, and let me just do this. This will be easier for me. Okay, that's done. Oh, that's what's confusing it. I had the pin too close to the thing. Okay, 10.4. The length is 15,840. And we're going to divide that by... Okay, so it has a diameter of 16.2 mils. Okay, this is a more advanced question than I wanted to start with, but... So the diameter is 16.2 mils. You're going to take 16.2 and square it to get your area in circular mils. So you can't just straight up take the 16.2. You have to take 16.2 and square it. So let's grab our calculator. 16.2 squared is 262.44. So now we're cooking. So 262.44. So what happened is we have the wire. we were given. They gave us the diameter, not the radius. So they gave us the diameter of 16.2. Wait, let's see. No, no, this is right. All right. So they gave us the diameter of 16.2. So you square that to get the area. So area in circular mils is equal to the diameter in mils squared. So now that we have the diameter in mils squared, so 10.4 times 15,840 gives us 164,736. Then we're going to divide that by 262.44, 627.709. So let's drag our thing, and 628 ohms is our answer. Do we have an explanation? We do not have an explanation. .2 times 1,000 squared. It is not 16.2 times 1,000 squared. Oh, you're saying, so 16.2 is mils. You would be trying to get to inches, is what that 16.2 times 1,000 would be how many inches wide it is. 16.2 is a very, like, mils is, they measure paper and plastic in sheets of plastic in mils. You can look at a package of trash bags and see how many mils thick the trash bag is. And usually it's like 8 mil is a pretty thick trash bag. Alright, so let me put that back up. Let me write down the, and you can pause this. I'm going to clean this up a little bit. All right. So, back to the questions. And there will be some easier questions than this later on. You've already done this quiz. I'm just going over it. There's some easier questions. If I was a responsible teacher, I would move this question further back in the lesson. Cross-sectional of American can't talk. The cross-sectional area of American conductors is expressed in units called circular mils. Yes. Of note, mil foot is how the K value of a material is measured. The K value of a material is the resistance of a piece of that material that's 1 foot long. 1 mil. It's 1 foot long and 1 mil in diameter. It's called a mil foot. To explain how to calculate the approximate cross-sectional area of a conductor in circular mils. Okay, so this is that other part that I explained. Measure the diameter of the conductor in inches. Ah, yes. So measure it in inches. So if, for example, back to my whiteboard. Where's my delete? Okay. So let's say you have a wire that is 0.5 inches across. It's a half inch across. So you're going to take in inches, multiply it by 1,000. A mil is a milli-inch. It's 1,000th of an inch. So 0.5 inches times 1,000 will give you 500 mils. And then now that you're in mils, you take the diameter in mils squared will give you your area in circular mils. That M is so ugly. All right. So now that you have 0.5 inches times 1,000 equals 500 mils, then you're going to square 500 squared should give you 250,000. Just as an example. I feel like this is a question and a couple questions too. So, like with those numbers. Calculate the resistance of a piece of aluminum wire with a diameter of 100 mils and a length of 2 miles at 68 degrees Fahrenheit. The 68 degrees Fahrenheit is because the K value is dependent on the temperature. In your book, they give you the K value for aluminum. I think it's 17 point. Okay, there's my DC theory book. It's thank you, Jacob. 17.7. So 100 mils. I'm just going to drag this up high. So we have 100 mils. So remember, R equals K, which we found was 17.7. Length of 2 miles. So R equals K times L. Does Control Z work on this? It does. All right. 5,280 is going to be 10,000. 10,560. And then our area in circular mils is 100 squared, which is 10,000. Oh. Where's my, oh, gotta move my, pick up my hand. All right, 17.7 times 10,560 over 10,000. A lot of this is going to cancel out. But let's go ahead and do this. 18.7 times divided by, yeah, 18.69. Unless this question said use the approximation method. But it couldn't have because this is not copper. The approximation method only works with copper. I will explain the approximation method in a second. I'm sure that... Okay. What is the approximate gauge of a wire that has a diameter of about 100 mils? So in your book somewhere nearby should be wire gauges. About 100 mils is 10,000 circular mils. So which size of wire is about 10,000 circular mils? In your code book, which you don't need to get that out right this second. Chapter 9, Table 8 in your code book will give you all the wire sizes based on circular mils. So if you were like ever out in the field and you were like, what size wire is this? There's no label. You could measure it, convert it to mils, square it, and then look it up in your code book. Probably somewhere around page 74, like Jacob would. Page 73. That's what I was thinking. I know this is so I know this is tiny, but page 73 is where that is, and you just go down the circular mils column until you get to about 10,000, and that's number 10. Number 10 is the easiest to remember circular mil area size because it's 10,000. I mean, it's not the easiest. 500 kc mil is 500,000 circular mils. It's the name of the wire size. So yeah, that one's easier. I'm not answering your phone call right now. Reed, if you're watching, why would you be calling me? The resistance of a specified length of wire of a certain type is directly proportional to its blank and inversely proportional to its cross-sectional area. So, directly proportional means as that number goes up, the final number goes up. If you look at our formula, the K value isn't changing with a specific length of wire or a piece of wire. But it's directly proportional. The R is directly proportional. So if L goes up, R goes up because it's longer. That's pretty common sense. Let's see how we did. All right. Specific resistance is also called blank and is abbreviated with the capital letter K or the Greek letter rho. I put it in parentheses. That's anyway. It's also known as resistivity. It's K. It's the K value in that formula that we had. Okay, so that was the last question. I'm going to leave this screen up for a second, just so it's up for a minute, and you can catch it where if you're clicking through the video, you can catch it pretty easy. All right. So now I'm going to take down this this quiz, and let me combine 6 and 7. And there is not a quiz for lesson 8. I think I put everything in lesson 7. There's not a quiz for lesson 8. We will circle back to that at another time if we need to. All right. Launch, quiz, lesson 6 and 7. All right. Quiz is up. you guys are welcome to do it. And if you don't come back for the last live stream, y'all have a good evening. I do that every time.